This is a solution key to Melham's Exam 2 from Math 110C at City College, Calculus 3. And number 1, find the domain of the function. Cosine t cubed can be anything, but radical t plus 1 has to be greater than or equal to 0. 5 minus t has to be greater than or equal to 0. This gives me t greater than or equal to -1. 5 minus t greater than 0 means 5 is greater than or equal to t, or t is less than or equal to 5. Both of these have to be true, so the domain is bracket 1, 5. Number 2, it's pretty much just plug in for that one and that one. This one, you can do a little bit of algebra, or you can do L'Hopital's rule. If you remember L'Hopital's rule, let me do the algebra. So the y component, limit t approaches 1 of 1 minus t over t plus 1 t minus 1. 1 minus t divided by t minus 1 is -1. So that gives me the limit as t approaches 1 of -1 over t plus 1. Now we get -1/2. So radical 2, -1/2, cosine of 1. Number 3, x is e to the negative t, which is 1 over e to the t. That happens to be y, since y is e to the t. So x equals 1 over y, or y equals 1 over x. But you're only in the first quadrant. So here's the graph of what that looks like. At t equals 0, plug in 0, you're at the point 1, 1. Okay, and if you're at the point t equals 1, then you get 1 over e comma e, which means you're going this direction. Okay, then r prime is negative e to the negative t, e to the t. Plug in 0, you have -1, 1. So here is a direction vector or position vector, 1, 1. And there's r prime, the tangent vector, -1, 1. Okay, so it looks like so. Okay, number 4, find unit tangent vector. So r prime is 4, 3 cosine t, -2 sine t. Plug in pi over 6. 4, 3 times cosine of pi over 6 is radical 3 over 2. -2 sine of pi over 6 is 1/2. So the tangent vector is 4, 3 radical 3 over 2, -1. Unit tangent vector, take this and divide by the square root of 4 squared, 16. 3 radical 3 over 2 squared is 27 over 4 plus 1. This is common denominator is 4. 64 plus 27 plus 4 is 95 over 4. Okay, multiply top and bottom by 2. So that 2 will cancel that 2. So I have 8, 3 radical 3, -2 all over radical 95. 5, it's basically some integration. Let's see. So number 5, the integral of 2 cosine 2t is sine of 2t. Integral of negative sine 2t is 1/2 cosine 2t. The last one, t sine of t, you have to integrate by parts. So you should show me the integration by parts. So little timeout. Integral of t sine of t dt, let u be t, dv is sine t dt, du equals dt, v is negative cosine of t. So I is u times v, negative t cosine t, minus the integral of v du, so it's minus a minus cosine, so it's positive cosine. So that comes out to be sine of t. So this should be negative t cosine t plus sine of t plus c. This is plus sine of t plus c. All right, so this is what I have for the antiderivative. Okay, plug in pi over 6 and plug in 0. So sine of pi over 3 minus sine of 0. And the middle one is 1/2 cosine pi over 3 minus cosine of 0. And minus pi over 6 cosine pi over 6 plus sine pi over 6 minus 0 plus sine of 0 is 0. So that's nothing there. Okay, sine of pi over 3, sine of 60 degrees is radical 3 over 2. Sine of 0 is 0. Okay, cosine of pi over 3, cosine of 60 degrees is 1/2. 1/2 times 1/2 is 1/4. Minus a cosine of 0, which is 1. And then this is negative pi over 6. Cosine of pi over 6 is radical 3 over 2. Plus sine of pi over 6 is 1/2. Okay, so radical 3 over 2 minus 3/4. And getting common denominator, negative pi radical 3 plus 6 all over 12. Okay, 6. R prime, or L is the integral from 0 to 1 of the magnitude of R prime. So square root of 2 squared plus e to the t squared plus negative e to the negative t squared. That's 2 plus e to the 2t plus e to the negative 2t dt. This factors into e to the t plus e to the negative t squared. So when I take a square root, I have e to the t plus e to the negative t. So I integrate that, e to the t minus e to the negative t from 0 to 1. Plug in 0, you end up with 0. Plug in 1, you have e minus e to the negative 1, or e minus 1 over e. Okay. Okay, number 7. This was maybe the hardest. Okay, find a unit tangent vector and a unit normal vector. Okay, so r is 1/3 t cubed, t squared 2t. So r prime is t squared 2t2. T prime is r prime divided by its magnitude. So t squared 2t2 divided by the square root of t to the 4th plus 4t squared plus 4. That happens to be t squared plus 2 squared, whose square root is t squared plus 2. Unfortunately, these aren't constant, so you have to actually take the derivatives. So n is t prime divided by magnitude of t prime. Fortunately, this one, rather than doing the quotient rule, you can think of it as t squared plus 2 minus 2. So then you get 1 minus 2 t squared plus 2 to the negative 1. That's easy to differentiate. Okay, and that actually happens to be the opposite of this. So once I differentiate this one, I take the opposite to get the third component there. Okay, so and the z component is 2 t squared plus 2 to the negative 1. Okay, so dx dt is 2 t squared plus 2 to the negative 2 times 2t, 4t over t squared plus 2 squared. I already know that dz dt is going to be the opposite. Okay, so for the z component, it's negative 4t over t squared plus 2 squared. dy dt, the middle one, so that one I do have to do the quotient rule. So it's bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. This comes out to be 2t squared plus 4 minus 4t squared over t squared plus 2 squared, or 4 minus 2t squared over t squared plus 2 squared. Okay, so t prime comes out to be this. Okay, now you're trying to find a unit normal vector. Okay, so we got the t prime. You can take any multiple of that. So that means it's easier to just use this expression. In other words, just drop this or multiply each of these components by t squared plus 2 squared. You're going to end up with the same normal vector. Okay, so to do the calculation, I'll just do 4t, 4 minus 2t squared, negative 4t. That's much nicer. All right, so the unit normal is 4t, 4 minus 2t squared, negative 4t over the square root of this thing squared, which is 16t squared. This thing squared, which is 16 minus 16t squared plus 4t to the 4th, plus this thing squared, which is 16t squared. So you're going to have a 16t squared minus 16t squared plus 16t squared. Okay? So that gives you 4t to the 4th plus 16t to the 2nd plus 16. Okay, very conveniently, that's 2t squared plus 4 squared, whose square root is 2t squared plus 4. Okay, so I basically have this, and to make it nicer, I factor out the 2, take out a 2 from everything. So the best final answer, 2t, 2 minus t squared, negative 2t divided by t squared plus 2. Okay, 8, find the curvature. So first, I take r prime. So r prime is negative sine t, cosine t. R double prime is negative cosine t, negative sine t. So a lot of negatives, unfortunately. Cross product, r prime cross r double prime, I, j, k, negative sine t, cosine t, negative cosine t, negative sine t. So I will be sine squared plus cosine squared, 1. And then minus j sine squared plus cosine squared, so negative 1. And then the k component is sine cosine minus sine cosine, so that's 0. Okay, and let's see. So k is magnitude of the cross product, magnitude of 1, negative 1, 0, that's a 0, over the magnitude of r prime q. Okay, so r prime was, where did it go? Here. So the magnitude is going to be sine squared plus cosine squared, sine squared t plus cosine squared t, which is 3, and sine squared plus cosine squared is 1. Okay, so radical 2 over square root of 1 plus sine squared of t cubed, or you can write it as square root of 2 over 1 plus sine squared of t to the 3/2 power. Okay, 9 should be pretty easy. So velocity is first derivative. Okay, so the first derivative is 1, 2t, 3t squared. And then they tell me to plug in 2. So 149, velocity vector. Acceleration, second derivative. So 1, 2, 6t, plug in 2, 0, 2, 12. Speed is the magnitude of the velocity. So square root of 1 squared plus 4 squared plus 9 squared, radical 98. You can simplify it if you want, but I'll leave it as radical 98. You can make it into what? 49 times 2, 7 radical 2. So that's okay. Maybe I should write that down also. 7 radical 2. Okay, and then tangential and normal components. So r prime is negative sine t cosine t 1. Double prime is negative cosine t, negative sine t 0. Dot product, that times that is sine t cosine t. That times that is negative sine t cosine t. That times that is 0. Add them all up, you get 0. R prime cross R double prime, ijk, negative sine cosine 1, negative cosine, negative sine 0. So I is nothing minus a minus sine t, so sine t. Then the opposite of nothing minus a minus cosine, so it's negative cosine t. And then k would be sine squared minus a minus cosine squared, so that's 1. Okay, so what's the magnitude of the cross product? Square root of sine squared plus cosine squared plus 1, radical 2. And magnitude of r prime, so magnitude of r prime is square root of sine squared plus cosine squared plus 1. That's 1 plus 1, so radical 2. So a sub t by formula is dot product over magnitude of r prime, 0 over radical 2 is 0. A sub n is magnitude of the cross product divided by radical 2, and it comes out to be 1. All right, so these are the solutions to Milham's Calc 3 at City College exam number 2, Math 110C.